What is the effect size and Cohen's d? Effect size in statistics is related to the p-value or the probability of the null hypothesis being correct. As the p-value goes down, the effect size will go up. Basically, it is the measure of association or sizes between variables. Cohen's d gives the rule of thumb for the effect size. 0.2 would be a small effect size, 0.5 would be a medium effect size, 0.8 would be a large effect size. Basically, it is how far the two groups are away from each other.
All right, explain this to me like I'm a 2-year-old, okay? Because there's an element to this thing I just cannot get through my thick head.
Effect size is a statistic that measures the magnitude of the relationship between two groups of data for comparative purposes. There are several ways to measure effect size. Correlation Pearson R, regression R coefficients, coefficient of determination or R squared, and Cohen's d. The one that we care about here is Cohen's d. The equation for Cohen's d is d equals m1 minus m2 over sd pooled. m1 is the mean for group 1, m2 is the mean for group 2, and sd pooled is the standard deviation for both groups. Here is an example equation. How many days did it take to get over the influenza virus using bed rest? Here is your data set. By adding up all the numbers and dividing by how many numbers there are, in this case 10, you get a mean of 4.9. Now we are going to look at how many days it took people to get over the influenza virus who didn't use bed rest. Here is your second data set. Following the same process as before, we add up all the numbers and divide by how many, which gives us a mean of 5.6. Now we need to figure the standard deviation, or SD, of each data set. Let's fly through this pretty quickly because we should all know how to figure an SD at this point. Here's the equation. Find the mean, subtract the means from each number and square the result, figure the mean of those numbers, and take the square root of that answer, and voila, the SD for both data sets. We are going to take those data SDs and stick them into the equation to get a pooled SD. Again, we are going to go through this pretty quick. And bam! SD pooled equals 0.208. We are almost done. We just have to take all of our results and stick them into the Cohen's d equation from the first slide and figure it all out. Voila! Cohen's d equals negative 3.365. Well, what does that mean? This was what I did not understand. What purpose did this number have? Basically, there is a negative 3.365 effect size between the two groups of data. Here are some histograms of the data sets. Visually seeing it helps make it easier to understand. Merging the two graphs together shows that the Cohen's d is the difference between the two groups. That 100% of the control group will be above the mean of the test group. Thank you.